All right, in this case, we want to look at the graph of a rational function. And we're going to get a list of about 7 guidelines to help us do this. So we've got our rational function there. The first guideline is simplify f if possible. Second, find and plot the y-intercept. 3, find the zeros of the numerator. And 4, find the zeros of the denominator. This is going to get us our asymptotes and wholes. Then number 5 is find and sketch any other asymptotes. This includes horizontal and slant. Plot at least one point. We're not going to worry about that. Then use smooth curves to complete the graph. Okay, so let's consider the function x squared minus 4x minus 5 over x squared plus 4x minus 12. And we're going to simplify it if possible. All right, so the first way to start to simplify is to see if we can factor x squared minus 4x minus 5 factors into x minus 5, x plus 1, x squared plus 4x minus 12, factors into x plus 6 times x minus 2. So f of x is going to be easier to work with if we write it as x minus 5 times x plus 1 over x plus 6 times x minus 2. So x can't equal minus 6 and x can't equal 2. Those are going to turn out to be vertical asymptotes. Now, after we do that, we find and plot the y-intercept, if any, by evaluating f of 0. So let's go back and let's let x equal to 0 in our f of x. And notice that when we do the proper arithmetic, we get that the y-intercept is at 5/12. All right, so we have simplified f. We've found the y-intercept. We're going to plot several of these things all together rather than doing the plotting one thing at a time. So don't forget, we're going to end up with vertical asymptotes at minus 6 and 2, and we've got the y-intercept. Now we find the zeros of the numerator. So we're going to set the numerator equal to 0, and then we should plot. But remember, we're going to let the plotting go until the very end. So our x-intercepts are going to happen at x minus 5 equal to 0, or in other words, x equals 5, and x plus 1 equal to 0, in other words, x equals minus 1. All right, now what do we need to do next? Well, find the zeros of the denominator. We sort of already did that. Notice there's our x-intercepts. Now we're going to find the zeros of the denominator and see whether ultimately they've got a whole or a vertical asymptote. So the zeros of the denominator, which we already listed in the very first, when we very first started this, one is at minus 6 and one's going to be at 2. Those are the zeros of the denominator. Those are going to be our vertical asymptotes. Okay, now we are going to find any other asymptotes. So let's just review here a minute. We found the zeros of the numerator. We found the zeros. There's the zeros of the numerator. We found the zeros of the denominator. And right here are our vertical asymptotes at x equal to minus 6 and x equal to 2. Now the next thing is, are there any other types of asymptotes? This includes horizontal and slant asymptotes. So the next thing we need to do is go back and revisit our function. And notice other asymptotes. Degree of the numerator equals the degree of the denominator. They're both equal to 1. So there will be a horizontal asymptote at y equal to 1. All right, now we have at this point found our horizontal asymptotes, and we're going to say we know how to graph well enough. We're not going to try finding those others because we'll probably use a computer algebra system to graph anyway. So let's just look at using smooth curves. All right, there's our function. There's what we know. Y-intercept, X-intercept, vertical asymptote, horizontal asymptote. Now, it's interesting here, something that I haven't pointed out to you yet, is that it's sometimes possible for a function to cross its horizontal asymptote. We do that by setting the function equal to the horizontal asymptote and seeing what happens. And look at that. Our function's going to cross that horizontal asymptote at 7/8. It's kind of an interesting phenomenon that can work. Now I'm going to attempt to graph it, and you know my graphs aren't the best, but we're going to give it what we call the old college try here. We're making some marks on there as to where we're going to plot things. We've got there's one of the vertical asymptotes. We had the Y-intercept, we had the X-intercept, and there comes the second vertical asymptote. There goes the horizontal asymptote. And so now I'm going to attempt to sketch that. You notice I just marked x equals 7/8 because that's where I've got to cross my horizontal asymptote. So here we go. Slowly, slowly, it's coming. All right, x equals -7. See, what we're doing here is to see where, this is where you do need to plot some points. We need to see which area that graph's going to be in. So when y equals -7, it's positive, and notice where I'm going to draw that piece. Aha, right there. Now let's go over and try something to the right of the other vertical asymptote and see where it's going to be. It's less than 0, so that's going to put it there and go up. We could have guessed that because of the fact that it crossed the x-axis there. And then it's pretty easy to graph the middle piece because we've got an x-intercept, a y-intercept, and a place where it crosses, and we have to have it being asymptotic. So consider this graph as drawn by a computer algebra system. There's our function in red. The vertical asymptotes are in green. The horizontal asymptote is in blue, as is where it crosses its horizontal asymptote. We have some x-intercepts, and we have a y-intercept.